Hey guys, welcome to this video on part B of your student experiment report. Today we are talking about the data analysis. So you've conducted your experiments, you've recorded everything, and now you're ready to get into putting it into a table, into graphs, and saying what you're seeing. So I will begin with this infographic. It shows us the type of data analysis you may perform depending on your research question. So if you are talking about differences between groups, as in if your question says, are there differences in the total number of duckweed population based on whatever group that duckweed is in, then you will perform different data analysis t-tests compared to if you looked at, is there a correlation between variables, as in is there a relationship between variable 1 and variable 2, then you will perform what is called a regression, and that is based on creating line graphs and looking at trend lines. And a regression is essentially saying how strong is that relationship between those two variables. So today we are not going to talk about t-tests and regressions. We are just going to this section here. So we'll talk about data summary, creating a table that has a mean, SD, and SE. And this is the same no matter what question you have come up with. So let's get into it. To begin with, data handling and data analysis. Two slightly different things, similar. A set of numbers is more than just a set of numbers. The goal of analyzing or handling data is to reveal the story that data tells. It is important to distinguish between the two now. So data handling involves identifying outliers, summarizing data, and considering uncertainty in order to validate the data. Whereas data analysis involves applying statistical tests, such as t-tests or regressions. And in doing so, it suggests how reliable the data is. So before we can do anything, it is helpful to have the data analysis tool pack. Everyone should have this on their computer by now, so I will just go through it very quickly. In Excel, go File, Options, Add-ins, Go, and select the analysis toolpack. Once it is installed, you will see it here in your data tab when you are in Excel. If you have any troubles, you can jump on YouTube or just come back to this tutorial. So once you have that, you will have the ability to perform a data summary, and that involves having an input range and an output range. So if I jump over to Excel now, I'm going to delete this and let's just start again. So the way that we do that, if I just want to select one section of data here, there's my data analysis tab. You click on descriptive statistics and it provides you with this section, and it says input range. That just tells me what section of data do I want to look at. Click on the tab to go back. Labels are not included. I have not selected any labels. And output range, where do I want this table to appear? I'm going to say right there. So now summary statistics, I can click on OK, and there it is. So now it gives me my mean, my standard error, my range, my standard deviation. It saves a lot of time manually calculating these things. But now let's talk about what those things even mean. So the range is saying what was the lowest value and the highest value. What's that difference there? Automatically, it will give you a title for your information. It gives you standard deviation, standard error. We do not need to use confidence interval. So to say what standard deviation and standard error is, let's begin with breaking down some definitions. By looking at these figures, precision is a measure of how well a result can be determined. So here we have high accuracy, high precision. Here we have low accuracy, but high precision. Here we have high accuracy, but low precision. And here we have low accuracy and low precision. So precision is the degree of consistency, how close they are to each other, or deviation among measurements. And so standard deviation is an expression of precision. Whereas accuracy, this says doesn't matter how close they are to each other. How close are they to a true or accepted value? Standard error is an expression of accuracy. And so both of these together is what we call uncertainty. It's the consideration of both accuracy and precision of data. I'm going to skip to this section now and go over it quickly just to say standard deviation is it's a quantity that expresses how much all measurements differ from the mean of a sample. So remember, standard deviation is an expression of precision. How close are they to each other? How close are they? Or how much do they deviate? That's what we're talking about here, and we can use this formula to give us that value. We do not need to know the formula or how to use it. Just a bit of context. Whereas standard error is a quantity that expresses statistical accuracy, such as the mean of a sample. It is calculated from the standard deviation. Remember, standard error is an expression of accuracy. So again, just a bit of context, but let's look at putting this into a bit more context right now. So how to present and interpret uncertainty. Uncertainty can easily be shown in a table. So take this one for example. We have 3 different treatment groups. We have regrowth forest, new, intermediate, and old. We have sample size 15, 10, and 12. That's how many quadrats there are. Then we have for each treatment group the mean, standard deviation, and standard error. You can see that there's a number of samples for each one, and all these figures are very low, 0 point something. So whenever we have a table, we have to have a few lines accompanying what we are seeing, just discussing the uncertainty that is relevant to you when writing your report. So you could say the sample size for each regrowth forest was between 10 and 15. This allowed for the collection of sufficient and relevant data. Most of you guys are collecting at least 3 samples of data for each treatment group. So you could say something similar. The standard deviation, an expression of precision, and standard error, an expression of accuracy across all sites, 1, 2, 3, were relatively small. This implies that there was a similar degree of uncertainty across all sites. So the sites are comparable, and that uncertainty is not only similar, but very small. It's good. However, if you obtained data like this, again, 3 treatment groups, 15 samples for this one, 10 and 2 for this one, so much smaller. The sample size for the old regrowth forest, n equals 2, was substantially less than the other 2 sampling sites. Standard deviation, again, expression of precision, and standard error, and expression of accuracy in the old regrowth forests were higher than the other 2 sites. This implies there was a greater degree of uncertainty for this site relative to the other 2. Guys, I'm reading this to you because this is the kind of information, the kind of wording that you will be using whenever you have a table in your report. Not only will you have tables, but you will also have figures. So, When you have a figure, you also need error bars. Let's talk about how to create error bars. And when I say error bars, it's just a visual depiction of the accuracy of your data. So we're talking about standard error when we say accuracy. It's a visual depiction of these values on your graph. So error bars should be presented on column graphs. They should always be used rather than standard deviation bars. And you will have a table of information that has mean, standard deviation, and standard error. So you will create your graphs based on your mean values. Then in your graph, so how to do that, you just select them, make sure that your means are in rows. It is a lot easier to create graphs that way. Select inserts, choose a reasonable column graph, go 2D instead of 3D. And then once your graph is created, you will have this feature that appears, chart elements. You'll see here, you can select error bars. So click on that and it will give you this default length error bar. You want to make your own custom error bars based on your own standard deviation error values. So standard error values. So the way you do that, chart elements, error bars, little arrow, more options, custom, specify value. That will bring up this box here where you can select positive and negative values. That is saying how far up positive should it go, how far down should it go. They are the same value. So you select that and then you select the standard error for your two groups and it will automatically say positive, negative, they're the same thing for each A and B treatment group. So each mean now will have its own standard error bar on the graph. So I've been through this. In scientific writing, figures should be accompanied with figure captions, which appear below the figure. In general, this figure caption should include 1, a description of the figure, and 2, appropriate statistical output, and so that just means say values in your figure, and is presented in continuous sentences. Notice that figures have figure captions below the figure, whereas tables have captions. Those don't have it, but tables have above saying what they are. So that's all I'm going to talk to on this document for now. If I take you now to the QCAA exemplar, you've been through part A by now, so you're good. Now we're looking at part B. So the first title you'll have is processed data. It then shows us that the first table is just showing what kind of data analysis are you undertaking in your report. Dot point list saying what they are, and then table 1, so table caption above. Then it says standard deviation, standard error, mean, and then it gives an example of how those are calculated. So you can have a table like this. We're not going to include confidence intervals or percentage change because we don't need them. So underneath that, now we have table 2. This is going to be your data. So I will use this QCAA exemplar as a rough guide. It is not flawless, but there are things that we can take from this to help us structure the data in our report. The first thing is this. Again, table 2, notice that the caption is above. They have their treatment group in this column here, control and grey water. Your treatment groups will be different. You might have sunlight, direct sunlight, indirect sunlight, no sunlight, or you might have full strength fertilizer, half strength fertilizer, zero fertilizer. then you still will have, probably most of you, a few samples for each treatment group, 1, 2, and 3. 1, 2, 3. If you have any crazy outliers, you indicate that by shading the box. Then you can see you are, instead of calculating mass, measuring mass, you're counting the number of fronts. Instead of having hours, you're going to be having days. So day 1 up until maybe day 14. Then for each sample, you'll be able to calculate the mean, the standard deviation, and standard error quite simply using the data analysis toolpack. Instead of having percentage change though, you probably didn't measure the mass at the beginning and then the final mass at the end and saw how do you calculate percentage mass change? It's not required for this, so I won't go into it. But what you might have in this column is the total difference. So if you started on day 1 with 12 fronts in every sample for every treatment group, and by the end of day 14 you have 100 fronts, then you could have the total difference, which would be 100 take 12, 88 over here. Notice that you've got this information for each treatment group. Now, I will take you to the Excel document to show you how you might set out your data in the same type of fashion, but relevant to your study. So you'll have treatment group. Pretend I have the research question, how does duckweed grow over 3 days in, let me rephrase that, because we are refining our research question to have either difference or correlation. So my question is there a difference in total number of duckweed population after 3 days, this is a terrible study, in using bottled water compared to pond water? So I want the mean, standard deviation, and standard error. You can select your days. That's the information we're going to be using. So pull up the data analysis toolpack, descriptive statistics, okay, input range. Let's include the labels this time. Yep, that's all of them. Let's say we're including the labels in the first row. The output range, let's put this table over here and create summary statistics. Looks good. So here we go. Day 1, day 2, day 3. We now have our mean for each day. So I can see, okay, the mean for day 1 was 12. That's because we started on 12. The mean for day 2 was 16. The mean for day 3 was 24. Standard deviation for day 1 was 0. There was no deviation. That makes sense. Standard deviation for day 2 was 1. Standard deviation for day 3 was 2. Standard error for, we have 0, 1. So then you can just plug in the rest of your values. And you are most likely going to be going for 14 days. So your tables are going to be a lot bigger. You're going to have maybe 3 samples. Yep, cool. But then you'll have the same thing for all your treatment groups. That is your data table that you will put into your reports. And that's pretty much it. Hey. And then from each data table, you will be stating what is being seen in these data tables. So here you can see that in the exemplar, they are saying that they have looked at the biomass change in these tables for the 2 different treatment groups. The standard error has been used as a measure of, you could say, accuracy. And the largest standard error for this particular treatment group may suggest higher random biological variation. So essentially, they're just saying what is being seen in these tables of data. So just to finish off this introductory lesson to part B, data analysis, let's come back to this picture here. So we have looked at how to calculate mean, standard deviation, and standard error. We have talked about what each of those standard deviation and standard error represents. And together they are an expression of uncertainty. Before we can move on, before we will look at how to perform t-tests or how to perform regressions, you need to know, does your question specifically and clearly talk about differences between groups? As in, is your question clearly stating, is there a difference? Or is your question clearly using the words, is there a correlation between? We need to just figure that out before we move on. So guys, refine your questions so that next video you will know exactly which path you are going to be taking. Then after that, we will talk about how to write up what you are seeing into words. I hope that this is a helpful beginning for you when it comes to data analysis. So all the best with your reports, guys. God bless, and I'll see you next time.